Hi friends, in this class we will be doing important concept of number system, that is the unit digit. What will be the unit digit of any number raised to certain power? First look at this table. We have the powers in the row and the numbers in the column. 2 to the power 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power 4 is 16. So the unitary digit, if you raise 2 to any power, follows a repetition or cycle which is 2, 4, 8, 6. Again 16 into 2 is 32, 32 into 2 is 64. So you see a repetition of the unit digit as 2, 4, 8, 6, 2, 4, 8, 6 and so on. We call this as the cycle of 2 is 4. The cycle of the unit digit of 2 raised to any power is 4. What it effectively means is the unit digit of 2 to the power 1 is same as the unit digit of 2 to the power 5, is same as the unit digit of 2 to the power 9, which is 2. Let us check the same for 3. If you look at the powers of 3, 3 to the power 1 is 3, 3 square is 9, 3 cube is 27, 27 into 3 is 81, 81 into 3 is 243. Again, if you multiply 243 by another 3, then the unit digit will be 9. So the cyclicity of 3 is 3971, again 39. So again after every fourth power, the unit digit repeats itself. So the cyclicity of the digit 3 is also 4. That means after every fourth power, the unit digit will be same. Let us look at 4. 4 to the power 1 is 4, 4 square is 16, 4 cube is 64, 64 into 4 is 256 and so on. So we find the cyclicity of 2 here. The odd powers of 4 end in 4 and the even powers end in 6. We say that the cyclicity of 4 is 2. For 5 the cyclicity is 1 because 5 to the power 1 is 5, 5 square 25, 5 cube 125. So unit digit always remains 5. So cyclicity of 5 is 1. 1 in the blue color. Similarly, cyclicity of 6 is also 1 because 6 to the power 1 is 6, 6 square is 36, 6 cube is 216 and so on. So, the cyclicity of the digit 6 is 1. Look at 7. We have 7 to the power 1, 7, 7 square 49. If you multiply 49 by another 7, 7 9 is 63. So, we write 3 here. 7 3 is 21, so we write 1 here. 7 1 is 7. So cyclicity of 7 is also 4, which is 7 9 3 1, 7 9 3 1 and so on. So cyclicity of 7 in the black color is 4. Look at 8. 8 to the power 1 is 8, 8 square 64. Multiply 64 by 8, 8 4 is 32. Again 8 2 is 16. Again 8 6 is 48. So again the cyclicity of 8 is 4, which is 8 4 2 6, like that in red color. Cyclicity of 8 is 4. Look at 9. 9 to the power 1, 9, 9 square 81, 9 cube 729. So the odd power of 9 ends in 9 and even power of 9 ends in 1. Cyclicity of 9 is 2. So just like we said, we'll repeat 2 to the power 1 has the same unit digit as 2 to the power 5, has the same unit digit as 2 to the power 9 because cyclicity of 2 is 4. Let us take an example. What happens if it is 2 to the power 201? What will be the unit digit? We can write as 2 to the power 200 plus 1, which is 2 to the power 4. 200 is 2 to the power 4 into 50. So we can remove this. We are left with 2 to the power 1. Last digit of 2 to the power 201 will be 2. If you look at 2 to the power 202, we can write it as 2 to the power 4n. Because cyclicity of 2 is 4, so we break up 2 as 2 to the power 4n into 2 to the power 2. So 2 to the power 200 we are not bothered with, 2 square ends in 4. Similarly 2 to the power 202 will end in 4. Let us look at 3 cube. We already know that 3 cube ends in 7. And the cyclicity of 3 was 4. So if we have 3 to the power 15, what will be the unit digit? We write it as 3 to the power 4 into 3 because the cyclicity of the unit digit of power of 3 is 4. So 3 to the power 15 is written as 3 to the power 4 into 3 into 3 cube. Again This cycle part we remove. 3 cube ends in 27, so the unit digit will be 7. Let's look at a slightly bigger sum. 2 to the power 256 into 3 to the power 512 into 7 square into 9 to the power 10. We have to find the units digit. Well, 2 to the power 256 can be written as 2 to the power 4n. 2 to the power of 4 ends in 6. 3 to the power 512 can be written as 3 to the power 4k. 3 to the power 4 ends in 1. 7 square ends in 9, and 9 raised to an even power, that is like 9 square, ends in 1. So 2 to the power 256 ends in 6, 3 to the power 512 ends in 1, 7 square ends in 9, and 9 to the power 10 ends in 1. So the unit digit is 6 into 1 into 9 into 1, 6 9s are 54, so unit digit will be 4. In continuation of remainder, lemma on remainder, I would just like to remind you, any number divided by the next number, any integer divided by the next integer, the remainder is n. If n is divided by n plus 1, then the remainder is n, and as we did, remainder n can be written as minus 1. So say for example 4 divided by 5, the remainder is 4, we can write it as minus 1. So what happens if it is n square by n plus 1? Then first of all, in the lemma we have learned that n by n plus 1, the remainder is n, which is minus 1. Since it is n square, so we get minus 1 whole square. So the answer will be 1. Say for example 4 square divided by 5. 4 divided by 5, the remainder is minus 1. So we write minus 1 whole square divided by 5. Minus 1 whole square is 1. 1 divided by 5, remainder is 1. So if you have n by n plus 1, if you raise it to an odd power, then you get the remainder as n. And if you raise n to any even power and divide it by n plus 1, then the remainder is 1. What happens when we have n plus 1 to the power p divided by n? N plus 1 divided by n, the remainder is 1. So n plus 1 to the power p divided by n also, the remainder will be 1 to the power p by n, that is 1 by n. So answer will be 1. Say for example 5 to the power 100 divided by 4. 5 by 4, remainder is 1. So this sum reduces to 1 to the power 100 by 4, that is 1 by 4. So the remainder is 1. I hope this concept is also clear to you. Thanks and cheers.